Hello students, welcome to YourPedia platform. My name is Arun Pathania, and today in this video we are going to solve a question from the NPTEL assignments for the subject of hydrology, branch civil engineering in detail. This question is taken from this particular book where we have compiled all the NPTEL assignments for various subjects in a very systematic manner, and the question number is question number 44 and it's present on the page number of 287 of this particular book. So let us just read the question first. So we have been given these ordinates. These are the ordinates of a total flow hydrograph, or also called as a flood hydrograph or storm hydrograph, and for a catchment of area 796 kilometers. So area of the catchment is also given, resulting from a 1 hour storm. So this rainfall was occurring for a duration of 1 hour, and for that a hydrograph has been made. So it will be a 1 hour duration flow hydrograph or flood hydrograph. At 1 hour interval were observed to be this or these are the ordinates that has been given, and we have to now determine the peak ordinate of 1 hour unit hydrograph and 2 hour unit hydrograph for this particular catchment. Now, so what is then? We have been given flow hydrograph. From this flow hydrograph, we have to prepare the unit hydrograph. The flow hydrograph is of 1 hour duration, so we can easily prepare the unit hydrograph of 1 hour duration. But from 1 hour duration unit hydrograph, when we have to prepare the 2 hour duration unit hydrograph, then we have to use the superposition principle or S-curve technique. In this case, since 2 is a direct multiple of 1, we can directly use the superposition principle and find the result very easily. Otherwise, we have to use the S-curve technique in order to find the ordinates. So first, let me explain you what is hydrograph. Hydrograph is a curve between the discharge and the time taken in chronological order, which is available. So this discharge is going to be available at the outlet of a catchment because of some rainfall that is happening. Okay. Now hydrograph are of two types. One is your storm hydrograph or flood hydrograph, and second is your direct runoff hydrograph. Now in flood hydrograph, we take into consideration the total flow that is reaching the outlet of the catchment. Now this will contain a direct runoff also, and this will contain a component of base flow also. This base flow is independent of the amount of the rainfall that is happening. This is constant and this is coming every time. But in case of your direct runoff hydrograph, we only consider the direct runoff which is produced by a particular storm, particular rainfall event, and we don't consider base flow in it. So the ordinates of DRH will be equal to the ordinates of flood hydrograph minus the base flow. In this question, we have been given a total flow hydrograph. So a flood hydrograph has been given to us, and a base flow of 34 meter cube per second is also given to us. So in order to find the unit hydrograph, we first have to convert the flood hydrograph into direct runoff hydrograph, and then we can convert the direct runoff hydrograph into unit hydrograph. Now let us first understand what is a unit hydrograph. A unit hydrograph of dr duration is defined as a DRH. So unit hydrograph is essentially a DRH only. Okay, so but it's a DRH of dr duration storm when effective rainfall is 1 centimeter. So in case of unit hydrograph, the effective rainfall is taken to be 1 centimeter. But in case of your direct runoff hydrograph, effective rainfall can be of any value. But in case of unit hydrograph, the effective rainfall has been fixed and it has been taken as 1 centimeter. Now we will look at the relationship between the direct runoff hydrograph and the unit hydrograph. So how can we convert this into this? So let us look at that relationship. That relationship is the ordinate of a dr unit hydrograph will be equal to ordinate of dr direct runoff hydrograph divided by the effective rainfall, because this will going to have some amount of rainfall, some amount of x centimeter of effective rainfall, but this is having only 1 centimeter of effective rainfall. So in order to convert these ordinates into one another, we have to divide the ordinates of direct runoff hydrograph by the value of effective rainfall, which results into this particular DRH. Okay, so this we want to, so this is the formula that we have to use in order to derive the ordinates of our unit hydrograph. Now for this we need the amount of effective rainfall. So since in this question effective rainfall was not given, it was not given what is the quantity of effective rainfall. So that we have to derive from using this particular formula. As we know that the area under direct runoff hydrograph, is equal to the volume of direct runoff, and the volume of direct runoff is equal to effective rainfall into area of catchment. Okay, so we will equate both these things. So area under direct runoff hydrograph will become this into area of catchment. From here I can find that the effective rainfall is going to be equal to area under direct runoff hydrograph and area of catchment. Now area of catchment is already given to us, and area under direct runoff hydrograph we will calculate using the trapezoidal formula, because ordinates have been given to us at constant interval. So we can use trapezoidal formula to find the area under the direct runoff hydrograph. So here is basically the table that has been given to us. This is given to us at time. In the question it has been given that at 1 hour interval the ordinates are given. So I have taken the 1 hour interval, and these are the flood hydrograph ordinates that have been given in the question. Now from these flood hydrograph ordinates, I can find the direct runoff hydrograph ordinates, and for that I have to subtract base flow from each ordinate. So base flow of 34 has been given. I subtracted it from these ordinates, and I get the direct runoff hydrograph ordinates. As you can see, when the time is 0, when there was no rainfall was happening, the direct runoff was equal to 0. But the flood, the total runoff was not equal to 0. It was 34, because some base flow contribution was always there, even when there was no rainfall. So from here also we can see that the first and the last ordinate is coming to be 0. So it is a direct runoff hydrograph. It symbolizes that it is a direct runoff hydrograph. Now I have to find the area under the DRH. So for that I'll use a trapezoidal formula. Now what is trapezoidal formula? Whatever is the common difference or common interval, that divided by 2, and that will be multiplied by what? First and the last ordinate plus the remaining of the ordinates multiplied by 2. So the first and the last ordinates into remaining ordinates, the summation of remaining ordinates multiplied by 2, and this will be multiplied by the interval. Interval is 1 hour divided by 2. This is my interval by 2, n by 2. So but this is in hour, this is given in hours, and this is given in meter cube per second. So I have written their units also, so that I can easily convert them afterwards. So from here it became like this. Now from this I can write that this will become, I have to convert this into seconds. So I can write this much seconds into 8844 meter cube per second. From here I can write 3600 divided by 2 into 8844 will be equal to 1591 into 10 raised to power 6 or 92, I can also write, meter cube. So this is the area under the DRH. So this gives me the volume of the direct runoff because of that particular rainfall storm. So this volume is available with me. Now I can just I have to divide this volume by the area of the catchment, so I can get the value of effective rainfall. So the value of effective rainfall comes out to be, I divided this by the area of the catchment. Area of catchment was given in kilometer square. I converted into meter square. So I got my effective rainfall result in meters, but I'll convert that into centimeters, because for UH we considered the amount of effective rainfall as 1 centimeter. So effective rainfall is always reported in terms of centimeter only, so that we can only use the magnitude, and we equaled the units. So we are now only concerned with the magnitude of the effective rainfall, not the units of the effective rainfall. Then we prepare this particular graph. Time is given like 1 hour interval. We have written all these hours we have written, and then the ordinates of 1 hour DRH that we derived in the previous slide, we have written those ordinates. And then in order to achieve the 1 hour ordinate, the ordinates of 1 hour unit hydrograph, we have to divide all these ordinates by the value of effective rainfall. Effective rainfall was 2 centimeter, so I have to divide all these ordinates by 2. So when I'll divide all these ordinates by 2, I get these ordinates of 1 hour unit hydrograph. Now these are the ordinates of 1 hour unit hydrograph. और मुझे क्वेश्चन में पूछा था कि what is the maximum ordinate of 1 hour unit hydrograph. So what is the maximum ordinate? From here we can see that 608 meter cube per second is the maximum ordinate of the 1 hour unit hydrograph. And if I have to find the 2 hour unit hydrograph, so what I have to do? I have to use a superposition principle. So superposition principle, I will lag this UH, the ordinates of this UH by 1 hour. I lag them by 1 hour, then I add both things. What I get? I get the key, there is 2 hour, the whole duration becomes 2 hours now, but the effective rainfall is 1 centimeter plus 1 centimeter, 1 centimeter plus 1 centimeter, so 2 centimeter. But for UH, what is the effective rainfall? 1 centimeter. So I have to again divide by these ordinates by 2. So what I lagged all the ordinates by 1 hour. This goes here, this 7 goes here, 32 goes here. These are lagged by 1 hour. Then I added both these ordinates. I added both these ordinates, so the duration becomes 2 hours, but the effective rainfall has now also increased, has also become double. Okay, so I have to divide by 2. So after adding, I divided these ordinates by 2. Therefore, I get the 2 hour unit hydrograph ordinates. So these are my 2 hour unit hydrograph ordinate for the same catchment. And from here I can see that the maximum ordinate of a 2 hour unit hydrograph is going to be 570.5 meter cube per second. We can see that the maximum ordinate of a 1 hour unit hydrograph is going to be more than the maximum ordinate of a 2 hour unit hydrograph for the same catchment. This we can see from this particular slide. So this was our question where we have been given a flood hydrograph. From that flood hydrograph we converted it into, and value of base flow is also given. So from that we converted it into direct runoff hydrograph. From direct runoff hydrograph we found the value of effective rainfall by finding the area under the direct DRH and dividing it by the area of the catchment. Now the value of ER is known to me. I can just divide it with the ordinates of the DRH. I can divide it with the value of ER. So I get the 1 hour UH ordinates. Now in order to find the 2 hour UH ordinates, I lagged these ordinates by 1 hour and then added both the results of both the columns and then again divided by 2 to find the ordinates of a 2 hour unit hydrograph. So in this case I can, after plotting these ordinates, I can find the maximum value for both the cases. And so this was my question. As we can see, we have to find the peak ordinates, peak or the maximum ordinates of 1 hour unit hydrograph and 2 hour unit hydrograph. So these we have found. So this was our question. I hope you must have understood this question. If you have any doubt, you can write to us and mention it in the comments, and we will try to reach you as soon as possible to solve your doubt. So that's it from my side. Thank you very much.